Hello, my name is Erland Gadde and I live in Sweden. This is my first real YouTube video and I'm gonna talk about flat earth. Most people laugh at flat earthers, people believing that the earth is flat, and they're right to do that because it's a really silly belief. But the number is increasing and they make a lot of YouTube videos where they are arguing for flat earth. And they can be dangerous because connected to their idea of a flat earth is also conspiracy theories saying that their powerful interests want us to believe that the earth is round. And so therefore they can be dangerous, and it's important to argue against them. And there are people on the internet who do that in a very good way. Simon Dan, Dave McKeegan, two fine examples of that. They look at, they watch flat earth videos and debunk them. They do a very good job. I am going to do it in another way. I'm going to make a video showing that the earth must be a globe and inviting flat earthers to debunk my video if they can, which they can't. Most people, when asked, don't really know how to prove that the earth is a globe. The flat earthers say that they're just indoctrinated from what they learn in school and everywhere else, and that the earth is indeed flat. But I'm gonna try to do this, show that the earth is a globe in a simple way, and I'm not going to talk about ships disappearing below the horizon. I'm not going to talk about NASA photos, if they're fake or not. I'm going to say what anyone can see who has been traveling a little. You don't need to travel in very much, just to a few places around the earth. I was about to say the globe, but that's of course right. I have been to the Northern Europe, Southern Europe, North America, both Canada and the United States, and to the Caribbean, and that's enough for seeing in the night sky that the earth must be a globe. What I have seen in the night sky cannot be explained if the earth is flat. If you have traveled a little, you might have noticed that the constellations have different positions in the sky and different orientations depending upon the latitude of your own positions. For example, the pole star or North Star, Polaris, the farther south you go, the more, the farther it moves toward the horizon. It has a high position in the sky, high altitude, here up in the north where I live. But in Southern Europe and the United States, and even more in the Caribbean, it is quite near the horizon. And also a constellation like Orion. Here, when we see it in the winter evening, just like now, it is not very high in the sky. It's about 30 degrees above horizon where I am. But it's much higher if you are farther south. In the Caribbean, for example, where I have also been, it's almost in the zenith when it's in its highest position. The flat earthers often talk about perspective. Yeah, that's because you have a different perspective. If you're in other places, of course you see them differently. And for example, I've never been on the southern hemisphere, but if I would be there, we would see that Orion is upside down compared to as it looks for us in the northern hemisphere. And the flat earthers think they can explain this also by talking about perspective, but they don't know what the perspective means. In particular, there is a flat earth YouTuber called Chris. He has a YouTube username CC. He lives in New York State. He has made a lot of flat earth YouTube videos, and one where he took a picture of the constellation Orion and taped it in his ceiling, and then just took photos of it from different parts or filmed it from different parts of the room and say, if I stand here, it has this orientation, and if I go on the other side of the room, it's upside down. And of course, my room, when I walk in my room, my floor is perfectly flat. That's not so. So that's perfectly possible that the Earth is flat, and we see Orion upside down if we're in the southern hemisphere compared to the northern hemisphere. And yeah, he's right, but still, he doesn't get it. His understanding is still wrong. What you don't understand is that the stars are very, very far away. And I'm going to demonstrate that by repeating his experiment. Now, it is my understanding that most flat earthers today, at least out on YouTube, including this guy Chris, believe that the Earth is flat. It's a flat disk with the North Pole in its center, and a large circle in the south, which is something like the South Pole, and it is supposed that there is an ice wall guarded by military because people can't go there. And above all of it, the sky is like a ceiling on a fixed altitude above the Earth, and on a distance which is quite small compared to earthly distances. And in this sky there are the sun, the moon, the planets, and the stars, all of the same altitude above the Earth. And we're assuming that in this demonstration here first. As you can see, I have glued a picture of Orion in the ceiling. And we have the left, on the upper left we have the red star Betelgeuse, and in the lower right we have the blue star Rigel, just as in the real Orion. So now we walk a bit and to the other side, to the southern side. We were on the northern side before. Now in the southern side we have Rigel in the upper left, the blue star, and Betelgeuse in the lower right, the red star. No problem. Here are 3 photos of Orion on the ceiling. This one, the first one, is taken from the north. This one from straight below, corresponding to from the equator, if it was on the Earth. And this from the south. We can see some differences here. This one is bigger than those two. That is because it's taken at a smaller distance. For this, we don't only have the vertical distance, but also the horizontal distance. And I should point out that all 3 are taken from the same height above the floor. It's about my own from my own eye level, approximately. And I tried to hold the mobile with the camera so that it was perpendicular to the line from the mobile to Orion on the ceiling, because that's how we watch stars in the sky. We were looking straight against them, bending our head so that we can look straight at them, straight against them, to our best ability. So I try to do all this to my best ability. And we can see the differences then. These two are smaller. That's because the distance is longer than this distance, which is only vertical, but here's both vertical and horizontal distance. Also, and almost even more important, these are obviously compressed in the vertical direction, so that it looks more like a square here than here. Here's more like a more oblong rectangle. Also here it's more like a square. It compresses in the vertical distance, less so in the horizontal, a little because of the longer distance, of course, and that is of course because the angle between the sight line to the Orion in the ceiling and the plan of the ceiling is, here it is a straight angle, it's 90 degrees, but here it is a less angle, so that causes that the distances are more compressed in the vertical than in the horizontal direction. If you wonder, this one could equally well have been turned around 180 degrees, so that we would have this star up, this side up and this side down. That's just because how I held the horizontal camera. If I turned it 180 degrees, it would just be the other way around. It's just like when you look up in the zenith, straight up from you, then you have to bend, and you have to bend your neck in about 90 degrees, if that's possible, lean back. But then you can see, depending on how you are standing, then you can see it either way. If you turn around 180 degrees, just to see the other way, you see the other way around. So that's no problem. It could actually well have been turned upside down here if I had chosen to direct the camera like this. It could have rotated 180 degrees. I didn't do that. But the important is the difference in the shape here and here compared to here. This is flatter here than here. And that's something that we don't see in the sky. If you look at Orion in the sky, okay, in the south it's upside down compared to north, but it still have the same size and the same shape. It is not in any way compressed in any direction or in any way distorted. Exactly the same shape wherever we look at it and whenever we look at it on Earth. And that is the point. If the stars, like I think most flat earthers today believe, including I think Chris CC, the stars are fastened to a flat ceiling above the Earth, above the flat Earth, at a distance that is small compared to earthly distances. Just then, it would be like here, the constellations would be distorted, like Orion here. It would be looking flatter, seeing from the north and from the south than from the equator. The fact that the constellations always look the same They might be oriented differently. We can see upside downwards would be if in north and south and so on. But always the same shape, the same size, and furthermore, the same relative positions. For example, Orion always have the same relative position to other nearby constellations like Taurus, Gemini, the Sirius in the dog star, and so on. This proves that the stars cannot be situated at a small distance, the same distance above the Earth. And with small I mean distance comparable to distances on Earth. It just cannot be so, because then the constellations would be distorted, just like we see here, then. And they are not. So this model with a flat ceiling above the Earth containing the stars, and the distance from Earth is comparable to distances on Earth, not much bigger than that at least. It's simply wrong. Okay, so this model with the stars on a flat ceiling quite close to Earth is wrong. But couldn't the stars still be quite close to Earth, but with another model, say that they are distributed through space in some random or chaotic fashion, but still quite close to Earth? Well, let's see. These objects hanging from the lamp are not Christmas decorations. They are to symbolize stars. I'm trying to film them at the correct angle and at the same height or level above the ground. Let's see what's happening. I've got me here. And you see, it's not easy, but you see what's happened that there. Sorry. You see that there. You see that their internal configuration changes all the time when we move the camera, when we move where we look at them from. But on the other hand, if we just move the camera very, very little, say a few centimeters, then the configuration doesn't change very much. But if you move much more, the configuration changes more. And just as the apparent pattern of these objects change when we move, when our position changes, the same happens with the stars if they are close to Earth. Say that they were thousands or tens of thousands kilometers away from Earth, and but still at different distances each of them, so that they would be like randomly distributed, but still quite close to Earth. Then, when we move on Earth from one location to another, say thousands of kilometers away, in different continents or so, then the apparent patterns of the stars, that is the constellations, would change. The constellations wouldn't look the same if we were, say, in Europe or in Africa or in America or in Asia, because just as you saw, the distances to the stars would then be quite small compared to distances on Earth, just as it was with those hanging objects from the lamp. But we don't see any such change appearances of the stars in the constellations. The constellations always look the same. That is, their sizes, their shapes, and their positions relative to other constellations don't change wherever we go on Earth. Okay, their orientations change. The Orion is upside down, seen from the southern hemisphere compared to from the northern, but that doesn't change its shape and how the stars are located within it, in its internal configuration, or its size, or its position relative to other constellations. So therefore, it cannot be that the stars are nearby and distributed more or less randomly. Also, it cannot be so that was commonly believed in the ancient and medieval times, that the stars were fastened on a sphere. If this sphere is close to the Earth, relatively close to the Earth. Because then again, just like when it was, just as if it was, if they were in a flat ceiling quite near above the Earth, the shapes and the sizes of the constellations would change for different locations on Earth. So the inescapable conclusion from all this is that the stars are not near the Earth. It's very, very far away from Earth compared to earthly distances. Not thousands or tens of thousands of kilometers away from Earth, but millions, billions, even more kilometers away from Earth. This is why we don't see any differences in the constellations, no matter if we travel around all of the Earth. It's just like for these hanging objects from the lamp. If we just move our position very little, a few centimeters or so, then the configuration just change a little. The apparent configuration just change very little. And that is because a few centimeters is a small distance compared to, say, the decimeters or so to the objects hanging from the lamp. But here, for stars, we see no difference at all if we move over all the Earth. So therefore the size of the Earth must be very small compared to the distance to the stars. Very, very, very small indeed. Otherwise we would detect a difference. And I don't think we can detect any difference even from different positions of Earth, even with the most advanced instruments and telescopes we have today. I might be wrong, but I think so. We can detect very, 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 very small differences if we wait 6 months when the Earth is on the other side of the Sun in the solar system. Then we can see very, very small parallaxes with very, very advanced and big telescopes. But for distances on Earth, I don't think so, although I might be wrong. Anyway, we have demonstrated for certain that the distances to the stars, no matter if they are in some kind of ceiling or at some kind of very, very, very large sphere or just randomly distributed, they must be very, 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 very far away from Earth. Therefore, if you want to object to my conclusions in the following of the video, you cannot do that and base your objections upon assumptions that the stars are close to the Earth. If you do so, you must first debunk what I said in the first part of the video, up to now. You must find some error in my argument showing that the stars are very, 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 very distant from Earth. If you don't do that, you cannot base any objection to my following conclusions on the assumption that the stars are close to the Earth. Here we have flat Earth and two observers at far away from each other, a large distance on the Earth from each other. They are both watching a star, the same star. And the star is far away compared to the distance on the Earth between the two observers. Now, since the star is so far away and the two observers have the same horizontal plane, the sight lines from the observers to the star are almost parallel. This means that the altitude of the star, this angle here, the angle from the sight line down to the horizontal plane, is almost the same for the two observers. We see a little difference here, but in practice, in reality, the star will be even much farther away than this, because this is the distance between the observers is like this. It will be very much far away, because we showed before that the stars must be extremely far away compared to distances on Earth, and then these two sight lines would be in practice parallel, and indeed the altitudes would we couldn't measure any altitude differences. I don't think we could do it with the kind of instruments we have today to do it. Not even with more modern technology. I think we could see any difference between those. So those lines are perfectly parallel. The observers see the star at the same altitude, with the difference that is not in practice not measurable. And the same would be true not only for the altitude but also for the horizontal position of the star. They would see it in the same direction. If those two observers turned, say, 90 degrees left both and looked at the star in this direction, they would see the same star, and they would see it in the same altitude also there. And the same would be true for any star they look at in any direction. So this means that if the Earth is flat, which means that they share the same horizontal plane, then they all see the same stars in the same direction, the same altitudes, the same horizontal directions. So the two observers must then see the same starry sky. No matter what direction they look, they see the same stars. No matter what altitude and what direction, they see the same stars. The starry skies are identical for the two observers. And this would be true for any observers on Earth, or any number of observers on Earth would see exactly the same star at the same time simultaneously. We must, of course, assume that they are looking at the stars simultaneously at the same time for the observers on the Earth, because otherwise they wouldn't see the same thing, because there is a relative motion between the Earth and the stars in the sky. In older times, it was believed that the stars were rotating around the Earth, but we know, of course, it's the Earth that rotates. But it doesn't matter which it which. The important is that they rotate in relation to each other, relative to each other. But so therefore we have to say that it should look at the same time, simultaneously. So any number of observers on Earth looking at the sky, at the starry sky, simultaneously would see exactly the same thing, exactly the same stars, not only relative to, not only the constellations relative to each other would have the same relative positions, but the absolute position would be the same in the same directions, the same altitude. They said they would see exactly the same thing. So, for example, if I right now near midnight in December would look to the south, well, I think it's cloudy now, so I wouldn't see anything. But if it wasn't cloudy, I would see Orion in the south. And I live in northern Europe, and if the Earth was flat, also a person in, say, South Africa would also see Orion in the south, in the same object, the same position in the sky as I see it. But we know it isn't so, because the observer in South Africa, he would see Orion in the north, and it would be turned upside down compared to how I see it. And if we take, say, a third observer in, say, Saudi Arabia, right now, they would be 3 hours before us, and then this observer would see Orion to the southwest on its way to setting. So the observer would not see the same thing in the sky. We would say the stars in different positions. Some have set for some observers, some have not, or so. And this is of course particularly true about the Polaris, the North Star, which everyone in the northern hemisphere always can see, but closer to the horizon, the farther south you go. As I have said, in Sweden, I see it in very high up in the sky, in high altitude. But the person saying in southern Europe sees it in a lower altitude. Same for observers in America and so on, and so. I have not been in the southern hemisphere myself, but I've been in the Caribbean, in the Dominican Republic, and there were the Polaris in a very low position in the sky, in the northern sky. And of course, I have not been in the southern hemisphere, but I know that the person in South Africa would not see the Polaris at all. So we see therefore that the Earth cannot be flat, because were it flat, we would see exactly the same thing in the starry sky. We see all the stars, all the constellations, exactly the same position in the sky wherever we were on Earth. But it's even so, we see different things. The constellations and the stars in different positions in the sky, depending upon from which point we look on Earth. And some stars would be visible for some observers, not for other observers, and so on. So, and that it wouldn't be so if the Earth is flat, and since then this assumption that the Earth is flat is contradicted by observation, we can see that we therefore must conclude that the Earth is not flat. The Earth cannot be flat; it doesn't fit observation. So the Earth is not flat. To reiterate, since the sizes, shapes, and relative positions of the constellations are the same from wherever we watch them on the Earth, it must be so that the distances to the stars are extremely great, that they are extremely far away compared to distances on the Earth. And this in turn implies that if the Earth is flat, then the starry skies would look exactly the same, with the constellations in the same exact positions in the sky for every observer on the Earth looking at them at the same moment simultaneously. So for any simultaneous observers on the Earth, the starry sky would look exactly the same if the Earth is flat. But this is not the case, so the Earth is not flat. And now we will take a look of how we can explain the different positions and orientations of the constellations seen from different positions on the Earth if the Earth is a globe. Here we have a round Earth as a globe, and we have two observers, one in the northern hemisphere and one in the southern hemisphere, and they are both looking at Orion, which is far away compared to the size of the Earth. Of course, here is we have drawn Orion as such that it was all the stars in Orion are about the same distance from Earth. It's not so, but it doesn't really matter. The point is that all stars in Orion are very, 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 very far from Earth, much farther away than this if this was to scale. It's not to scale, seriously. So the person in the north, the observer in the north, had this horizontal plane and this sight line to Orion, and this means that up is this direction for the northern observer, and therefore up he sees or up in this direction, and therefore this part of Orion is above this part of the Orion. But if we take the observer in the southern hemisphere, this person has this horizontal plane, and up for him is this direction. Therefore, when he's looking at him or her, he or she looking at Orion, then this is the upper part and this is the lower part of Orion, seen from this person's perspective. So therefore, these two persons, this person sees Orion upside down compared to this person in the north. And these sight lines here, they would actually be parallel. They're not quite parallel now, because the distance to Orion is not enough. It should be much, much, much greater if this was the size of the Earth, as we had talked about before. There's no difference in whether the Earth is flat or round in this respect. So these should actually be parallel, or essentially parallel, and therefore you see that this person sees Orion upside down compared to how this person sees Orion. The point is not that these two observers are at different locations and therefore see Orion differently, because in a cosmic perspective, the perspective of the distances to the stars, this distance is negligible, almost zero. Now the point is instead that they have different orientations. For this person, this is the up direction, this is down, and for this person, this is the up direction, this is down. It's therefore they see Orion differently, that they see them turned around, upside down in relation to each other. That's the reason. In fact, all observations of the stars in the sky ever made perfectly fit the hypothesis that the Earth is a globe. If there were any observations that didn't fit the hypothesis that the Earth is a globe, I'm sure that the flat earthers would tell us about it. So And I haven't said anything like this. So we can definitely consider it confirmed that the Earth is a globe. The Earth is definitely a globe. It's all those observations, even my own observations when I was traveling around to North America and Europe and so on. On the other hand, the flat Earth hypothesis do not fit the observations we can do. They do not fit the observation I made myself when I was traveling to North America, to the Caribbean, and so on. So we can just put throw the hypothesis of the flat Earth in the dustbin. The Earth is definitely a globe. To conclude, I will say a few words about the Antarctica expedition that took place now in December. This recently ended. On this expedition to Antarctica, both flat earthers and globe earthers were invited to see if they would see the midnight sun in Antarctica now in December. Because according to the standard flat earth model most flat earthers adhere to today, the Earth is flat with the North Pole in its center, and it's surrounded by mountains of ice that cannot be penetrated. They're guarded by militaries in the southern big circle. And the sun is going above the Earth at a relatively small distance between the two tropics, the tropics of Cancer and the tropics of the Capricorn. But this would mean that seen from the Antarctic, the sun will never be in the south, always be in the north. So if we in the Antarctic can see the sun doing a full circle, as it will if it's this kind of year, it will be in the south at midnight in the Antarctic, and this will then contradict this flat Earth model. It's not entirely clear how it will relate to other flat Earth models. But anyway, it's ended now, and of course the experiment showed that the sun did make a full revolution around the sky and was in the south at midnight, contradicting this flat Earth model. But on the other hand, my demonstration here actually shows that any possible any flat Earth model at all is contradicted by observations. So it maybe it's more general. But anyway, the Antarctica experiment was a very ingenious idea, which resulted was very embarrassing for a lot of flat earthers. Okay, that's all I have to say today or tonight, because it's night now, and I hope you can bear with me that this is my first real YouTube video. I know I'm very difficult to follow because I somehow interrupt myself and so on, and somehow don't talk sufficiently clearly. But I hope still it has been instructive, and as I said, any flat earther is welcome to try to debunk this, to try to find errors in my reasoning, just let me know in the comments, or put a message to me anyway. So bye bye, see you another time, another day.